Section 5.1, Exponents and Scientific Notation. All of Chapter 5 is actually a review. I am going to go over it fairly quickly because there are some things we use from Chapter 5 in the upcoming chapters. But I do want you to realize this really should have already been covered. So watch this video, go to the Chalk Test videos and the Khan Academy videos in Canvas as well if you need more practice. Please feel free to reach out to me or the Math Resource Center to get help as well. So properties of exponents. One thing I want you to remember is negative 2 to the fourth and parentheses negative 2 to the fourth are not equal. That is not the same answer. If you're looking at negative 2 to the fourth, you actually are just taking 2 to the fourth power. 2 times 2 is 4, times 2 is 8, times 2 is 16, and the negative stays out in front. When you have parentheses, that means you're taking negative 2 all raised to the fourth power. So negative 2 times negative 2 times negative 2 times negative 2 is a positive 16. So those are not equal. So you need to make sure you understand how to use parentheses correctly. So first, we'll look at the product rule. The product rule states that if we're multiplying x to the a times x to the b, notice that the bases are the same. We keep the base and we add the exponents with parentheses. Again, we keep the base and we add the exponents. So I kind of want you to understand why this is happening. I don't want you to memorize rules and not understand why. So for example, if we had x squared times x to the 7th, well, by rule, we know that it's going to be x to the 9th. But why? Because x squared is, if you write it out, is x times x. And x to the 7th is 7 x's. 1, 2, 3, 4, 5, 6, 7. Now look how many you have. 9. So that's where you get x to the 9th. So when you are multiplying, you add powers. So what would example 2 be? Well, we have 4 times 8. Those just get multiplied. We have the same base with multiplication. So when we're multiplying, we add exponents, and we get 32y to the 7th. Then on the next problem, in parentheses, again, if you look outside the parentheses, there is no power, so we're okay just to multiply straight across. So negative 6 times 7 is negative 42. When I multiply, I add power, so a times a is a squared, because each of those a's has a power 1. And b cubed times b would be b to the 3 plus 1 is 4. And then we have c squared still. So what is the rule of thumb here? You keep the base and you add the exponents. That's the product rule. The next rule is the power rule. And as you can see with parentheses, you're raising it to a power. So that's considered multiplication. When you have a power to a power, you keep the base and you multiply a times b. If there's more than one thing inside the parentheses and they're still being multiplied, you can distribute your power. But if they're not being multiplied, if they're being added or subtracted, you cannot distribute in the power. But at this point, we're going to distribute in the power, so we get x to the b and y to the b. If we're dividing, the same rule applies. X to the first power, y to the first power, all raised to the b, would give you x to the b divided by y to the b. All you're doing is distributing, so you're multiplying the power times every power. So the first example, x squared raised to the 5th. Why is that just x to the 10th? Because as we saw from the very first problem, x squared raised to the 5th says you are going to write x squared 5 times. And then when we're multiplying, we add power, so 2 plus 2 is 4, plus 2 is 8. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So again, don't try and memorize these rules. Understand why these rules are the way they are. So here you had to be very careful in example 2. And the reason why I had to be very careful in example 2 is because of that number. Many students forget that that number is also being raised to that power. Negative 4 has a power 1. So what we just learned at the top, we have to keep the negative 4 in parentheses and raise it to the 3rd power, because 1 times 3 is 3. X has a power 1 as well, so we get x to the 3rd. Now here we get 3 times 2, and 3 times 2 is 6. And then we get 3 times 6, which is 18. And then we need to simplify negative 4 to the third. So negative 4 times negative 4 times negative 4 is a negative 64. X to the third, y to the 6th, z to the 18th. So one more example for the power rule. We have parentheses with a power on the outside. So all of everything inside the parentheses has to get raised to that power. So we're going to distribute that power, so we end up with 3 to the 4th. Do you see how I still kept it in parentheses, just in case if it was a negative? This one's not, but use parentheses. And then 4 times 2 would be x to the 8th, all over, and then 4 times 3 is y to the 12th. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So 81 x to the 8th over y to the 12th. So what is our rule here? We keep the base and we multiply the exponents. But again, make sure you're understanding why, not just memorizing. All right, so the next problem, the quotient rule. X to the a divided by x to the b. Well, when we are doing this, we actually get x to the a minus b. But again, I want you to understand why. Let's do a little bit simpler example than this one that's given right now. If I had x to the 5th over x to the 2nd, according to the rule, we know it's going to be x to the 3rd. But why is that? Because on the top, we have 5 x's. On the bottom, we have 2 x's. Because it's all multiplication, we can go ahead and start canceling. And let's look what's left. X times x times x, which is x to the 3rd. So when we were dividing, we subtract exponents. Keep the base. So we got a 6 and a 3. We're just going to divide those out, and we get 2. We subtract 2 minus 1, and we get x to the 1st. And we have y to the 6th on top, y to the 3rd on bottom, so 6 minus 3 is 3. You don't need to put the 1. It's there just to show you that it does have a power, but you do not need to put that when you write your answer. So let's look at example 2. We had 18 t squared u to the 8th v all over 30 t squared u. Let's first try and work with our numbers. Is there anything that can go into 18 and 30? Well, 6. 6 times 5 is 30 and 6 times 3 is 18. So we're going to reduce that by 6, so we get 3 over and then 5. When we have a t squared on top and a t squared on bottom, we get t to the 0 power. Let's think about that. T to the 0 power. We'll talk about that in a second. And u to the 8th over u to the 1st would give me u to the 7th. And we still have a v on top because there was nothing to do with that v. So now what is t to the 0 power? Well, anything to the 0 power is 1. So this just gets to become a big old 1. And 3 times 1 is 3. So we get 3 u to the 7th times v over 5. Now we're going to talk about this power, the 0 power rule in just a second. But anything to the 0 power is 1, and I'll explain why in just a little bit. So what do? We keep the base, and we subtract the powers. But what happens if the variable with the power is bigger on bottom? We haven't had that happen yet. So say, for example, we had x to the 2nd over x to the 5th instead. Well, where would my x's be then? Well, if I reduce, I'm going to have 3 x's left on bottom instead of left on top. So what has to be on top is a 1. So we get 1 over x cubed. So x squared over x to the 5th equals 1 over x cubed. But if we use the quotient rule, it says take the 2 minus a 5. And 2 minus a 5 is negative 3. So do you see what happened? When you have a negative exponent, x to the negative 1/3, look what it turns it into, 1 over. So that's when we're going to now talk about negative exponents. So negative exponents never make the base negative. The negative exponents move things, if they're in the numerator, down to the denominator. If they're in the denominator, up to the numerator. So x to the negative a would be 1 over x to the positive a. It moves 1 over. Now this one, we had x to the negative a on bottom. So this x to the negative a wants to come up and become positive. So x to the positive a. Now don't get flip happy. Only negative exponents move things. Don't start flipping everything. Over x to the negative 6, the 3 does not move. The 3 stays on top. X to the negative 6 is going to be coming up and become a positive. So x to the positive 6. Nothing is left in the denominator. We don't need to put a 1. It's understood to be there. So we can just write 3x to the 6. So for example 2, we have 5x to the negative 4. All right. The 5 doesn't have a negative exponent. It has an exponent of 1. It does not move. The 5 has an exponent of 1. It does not move. So the 5 stays where it's at, but x to the negative 4th needs to go down and become positive. So we get 5 over x to the positive 4th. So negative exponents move terms. They don't make anything negative. So what is the zero power rule? The zero power rule states that anything to the 0 power is 1. And that's what I referenced to in this example right here. But why? All right, so if we had x to the 5th over x to the 5th, according to this rule up here, we should subtract the exponents. So 5 minus 5 is 0. So we get x to the 0 power. But we also know that x to the 5th divided by x to the 5th is 1. So what have we proven? We have proven that x to the 0 power is just 1. The x goes away, and you're just left with the integer 1. And lastly, x to the first power is just x. I just want you to realize that if you have a variable and the exponent is not shown, it has to be a 1. All right, so let's do some examples. I'll probably do the evens. And we'll see how many we can do together. All right, so I'll let you do the evens and I'll do the odds. So I'll give you the answers for these. You see if you can figure out why they turn out to be the way they do. So 6 to the 0 power. Anything to the 0 power is 1. We figured that out. At the very top of the previous page, we made sure you understood the negative is not being squared. So this is negative 9. Why would that negative be being squared? Is if it was in parentheses. Number 5. The 6 doesn't go anywhere. Where does b to the negative 5th go? It goes on top. So we end up with 6 times b to the 5th. On number 7, this is the product rule. When we multiply, we add powers. So x to the 3rd times x is x to the 4th. Y squared times y to the 4th is y to the 6th because we add powers. We keep the base and add the powers. And number 9, we multiply 2 times negative 3. Negative 3 is not an exponent. It does not move. You just multiply 2 times negative 3 and get negative 6. Now m has the power 1, so 3 plus 1 is 4. And n squared times n to the 9th is n to the 11th because 2 plus 9 is 11. So I want you to pause the video at this point, and I want you to try 2 through 10. Once you do the evens, 2, 4, 6, 8, 10, come back and see if you have the right answers. The answers to number 2 would have been negative 3. The answer to 4 would have been 1 over 16. The answer to 6 would have been c cubed over 9. The answer to 8 would have been 2 to the 9th power. If you multiply that out, that's fine. And the answer to number 10 is 1 over u to the 5th. So hopefully you've paused the video and tried those problems and then came back to check your answers. So there's a little bit more involvement when we get into variables in numerators and denominators and in parentheses and all that. So we're going to do these together. Number 11, the first thing I always want to make sure you do is if you have parentheses, get rid of parentheses. So it's kind of like order of operations. The next thing you want to do is get rid of any negative exponents. Some of you will be like, I want to work with negative exponents. Well, that's up to you. I would get rid of them. And then you're going to subtract if you're dividing or add if you're multiplying. So on number 11, do not move the negative 12. It is not a negative exponent. So, but we can reduce negative 12 divided by 3 is negative 4. When we are dividing, we subtract exponents, so we get j, that should be a j squared, because 5 minus 3 is 2. And now when I subtract 9 minus 12, I actually get k to the negative 3. Now when I subtract 9 minus 12, I get k to the negative 3, because 9 minus 12 is negative, and it's on top, so it needs to move to the bottom. So negative 4 j squared all over k to the positive 3. Now I want you to start realizing where the variable will be left depending on the powers. Do you see that 12 is bigger than 9? So if I would have written out 9 k's and 12 k's, your k's would have been left on bottom. But if you always want to do the top minus the bottom, you can, but then make sure you get rid of negative exponents. So on number 12, there are no parentheses. So the next thing to do is get rid of negative exponents. So all I'm going to do is get rid of negative exponents. So the 3 and the 9 stay. Let's work with the numerator. X to the 7th stays on top, y cubed goes to the bottom, and z to the 4th goes on to the bottom. Order doesn't matter because it's all multiplication. The 9 stayed on bottom, x to the 4 stays on bottom, y to the 5th gets moved up, but z stays on bottom. So all I'm doing is moving my negative exponents. And now I'll start reducing. 3 over 9 is 1/3. And we have 7 x to the 7th on top over x to the 4th. When we're dividing, we subtract exponents. So 7 minus 4 is 3. When we're dividing, we subtract exponents. So 5 minus 3 is 2. Now here I'm multiplying. So z to the 4th times z to the 1st would be z to the 5th. Again, feel free to stop the video, try these again. You don't have to continue working these right with me. Maybe you want to try them out and then come and check your answers. So on number 13, we have negative 3w squared, v to the negative 3rd, all raised to the negative 4th power. So negative 3 is going to be raised to the negative 4th power. W is going to be raised to the negative 8th power. And v is going to be raised to the positive 12th power. Why? Because this is your power to power rule. So product rule. Sorry, this is product rule. You're going to multiply negative 4 times 1, negative 4 times 3, 2, and negative 4 times negative 3. So this is the power rule. When you have parentheses raised to a power, distribute your power to every power. So remember, the next step is to get rid of negative exponents. So v to the 12th is going to stay on top. Negative 3 is still negative, but the 4 becomes positive, and w to the 8th is positive in the denominator. So the last thing to do is multiply out what negative 3 to the 4th is. Negative 3 times negative 3 times negative 3 times negative 3 would be negative 81. So v to the 12th all over positive 81 w to the 8th. So look at 14. Wow, we have parentheses 6x to the negative 2, all raised to the negative 2nd power, over parentheses 3x to the 6, y to the negative 2, all raised to the negative 3rd power. So what I would do, and I know some of y'all would want to do a different way to start it off, I would still distribute that power to every power. So 6 has a power of 1, so when I distribute, I get 6 to the negative 2. Negative 2 times negative 2 is a positive 4. Negative 2 times negative 3 is a positive 6. And negative 2 times 3 is a negative 6. In the denominator, negative 3 again has a power of 1, so we get 3 to the negative 3, x to the negative 18, and y to the positive 6. I like to get rid of my parentheses first. And then what would I like to do? Anything that has a negative exponent needs to get moved. So I'm going to move 6 to the negative 2 down, it becomes positive 6 squared. And 3 to the negative 3 is going to go up, so 3 cubed goes up. X to the 4 stays, y to the 6 stays, but z to the negative 6 moves down. Now in the denominator, x to the 18th goes up, but y to the 6 stays down. So that one stayed down, and so forth. So now, we multiply it out. 3 cubed, 3 times 3 times 3 is 27. All over 6 squared is 36. When you're multiplying, you add powers, so we get x to the 22. When you're dividing, you subtract powers, and 6 minus 6 is 0. So anything to the 0 power is 1, it goes away, and we're left with z to the 6. Last thing to do is to try and reduce. 27 over 36 can be reduced by 9. 9 can go into 27 3 times, and 9 can go into 36 4 times, and we'll keep everything else the same. So number 15, first thing I do to start off is distributing my power to every power, keeping that in parentheses. It would have been a good idea to use parentheses here, but since they were positive numbers, I didn't worry about it, but it gets to be a good habit to get into. So 3 to the negative 2, h to the negative 6, t to the negative 10. Now we're going to multiply all that, distributing your power. We get 9 squared, h to the 4th, t to the 8th. Any negatives need to go down. So we have 9b to the 4th, t to the 8th stays on top. 3 squared goes on bottom, b to the 6th goes on bottom, and t to the 10th goes on bottom. So multiplying out what 3 squared is 9, so we get 9 over 9. When we are dividing, we subtract exponents, and 4 minus 6 is negative 2, so it's going to go down and become a positive 2. And 8 minus 10 is also negative 2, so it's going to be going down and become a positive 2. Lastly, 9 divided by 9 is 1, and we do need the 1 on top because everything canceled out. So we have 1 over b squared t squared. And last problem, distribute your power to every power. We get x to the negative 8, and we still have x to the negative 3rd and x to the 4th. Again, some of y'all are going to want to work with negative exponents. I suggest not to. So this one goes down and this one goes up. So x to the 3rd goes up, x to the 8th goes down, and x to the 4th stays down. Now which direction you go is up to you. What I would do is I would go ahead and when I'm multiplying, I add powers. So I get x to the 8 plus 4 is 12. And then when I'm dividing, I subtract. 3 minus 12 is negative 9, so x to the negative 9. So that's just going to go down and become 1 over x to the positive 9. You don't have to show the step in between. If you know 3 minus 12 is going to be a 9 in the denominator with that variable, then that's fine to do.